Good morning, everyone.
Thank you, Iman. You can start.
صباح الخير. Good morning, everyone. This is Iman Adel, Sustainable Energy expert at Turkey, and I'm with you today to start together our webinar on district cooling potential and the challenges. We will have only 2 hours of webinar since it's Ramadan. رمضان كريم عليكم جميعا, and hopefully عيد مبارك كمان إن شاء الله قريب. So before starting, let me give you a brief about our day and flow of the presentation. We're going to start with the opening remark with Dr. Meged Mahmoud. Dr. Meged is our technical director at Turkey, and he's acting as executive director for the time being. Then we will go for presentations from ECUD to represent the district cooling plant in Egypt. This is one of the pioneer in our region based on the reports that we have done with the meetMED project and the researches that we did during the meetMED within the last 3 years. The report will be published soon, and you can see the whole analysis within it. Through the ACUD, we will have Engineer Haitham Ata. Engineer Haitham is usually representing ACUD with us, but we have lots of partners there who usually give us the support. We will then have a presentation from Engineer Ahmed Abdelghani, representing Allied Consultant. Engineer Ahmed will give us more introduction about the district cooling technologies and the new applications in Egypt. And if you have any technical questions about how it works, the main aspect of it, and how it's a success story in our project, please feel free to directly ask him. He's the one who can give us the answers here. Then we will have an overview on the project implementation, technical aspects, and the challenges from GasCool through Engineer Mohammed Darwish and Engineer Mohammed Wahdan. I was looking forward actually to have also more insights about the Palestinian case study, their technologies and the barriers, but unfortunately we have received apology from them today morning due to urgent commitments. So we'll consider them in another online webinar soon, inshallah. So Dr. Meged, please, you have the floor for the welcoming remark.
Thank you, Engineer Iman. It's a pleasure being with you today in this important webinar. This is part of a meetMED project. meetMED project stands for Mitigation Enabling Energy Transition in the Mediterranean area, and this is a project funded by the EU and developed by MEDENER, the Mediterranean Association for Energy Conservation, and also the Regional Center for Renewable Energy and Energy Efficiency. We are happy to host you, and in fact, the area of district cooling is one of the important pillars that we work on within meetMED project, is particularly on the activity 3 on appliances. And we in fact exceeded the concept of appliances, the general cooling systems, toward a very promising area for the countries to work on, which is district cooling. And Egypt is taking the lead in district cooling, and we are happy that we are partnering with the AUCD, the new administrative capital, and the company that is managing this AUCD, and our dear partner, Engineer Haitham, has contributed a lot to the discussion at the regional level, and we even convened a knowledge exchange mission where most of the Arab countries visited, a partner of the meetMED project, of course, visited the facility, which is very much advanced and reflects how Egypt is looking into the future through this modern advanced technology. In fact, meetMED project is looking at different areas like policies, like buildings, energy efficiency in buildings, energy efficiency in appliances, and we have tackled several topics like, for example, when we discuss the investments, we have tackled the platforms of putting more money into more funds into the energy efficiency sector at centralized, at decentralized level. And we have conducted several capacity development programs and knowledge exchange, issued several reports, among which you will soon see a report dedicated to district cooling. And I think this is a first of its kind in the region. And the colleagues are working on that now, on the final stages of the design. Further, when we conducted the work related to district cooling, in fact, we have also convened an interesting workshop that was hosted in Paris, in France, and where we had initiated together with UNEP, also there with the support of meetMED hosting this regional workshop, a discussion that at the end led to launching a very important initiative on national cooling action plans. And this National Cooling Action Plans initiative, in fact, was officially launched in Tunisia in the Decarbomed conference last year. And now we are working on producing a methodology for development of the cooling sector at the Mediterranean level and the MENA, Middle East and North Africa level. And hopefully we will see the cooling action plans spreading all over the region. We are trying to have some sort of a coherent, harmonized methodology that would allow countries to work in a way that even they can exchange not only at the knowledge level, but also at the, I would say, industrial and manufacturing level and know-how. And we are happy that we are having with us today Dr. Ahmed Abdel Ghani and Dr. Muhammad Darawish and Dr. Muhammad Wahdan, have been all active in designing not only for projects in the field of cooling and district cooling and centralized systems, not only in Egypt, but also across the region and in different locations. So we are happy that we are having them with them. You will hear insights, I believe, that are useful, and we are keen that to hear from them on their experience. Please expect us as RECRE and as meetMED to work more on this topic in the near future. We will be happy to support all our member states, and especially, of course, Egypt, where this activity is focusing on the progress and programs here in Egypt. We'll be happy to support and provide all technical advisory services, all capacity building, etc., that would help the country to move forward with the important domain of cooling, which is a major contributor to the emissions all over the world and especially in our region. Thank you very much for being with us today. I leave the floor now to my colleague Iman to continue with the webinar. Thank you very much. The floor is yours.
Thank you so much, Dr. Megid, for your welcoming remarks. And I would love also to give our greetings to Engineer Mustafa Hassanin. He's the activity leader of the whole district cooling activity within the meetMED project. Then I believe we can start now with our first presentation with Engineer Haitham Atta. So Engineer Haitham, please, you can start sharing your presentation and give us a small introduction about yourself and your background for our attendees.
Sorry, Iman, I don't think that Engineer Haitham has joined us yet.
So.
Engineer Haitham is not in the speakers list. You could continue, and I'm gonna send him an email now. Thank you.
Because I thought he was here, because he have sent me in the early morning. Can you just send him now? Maybe he has a connection error or a problem within his internet.
Iman, could we start with the next presentation till he joins, or would this be possible? Or we wait for him for a few minutes?
Let's give him, yes, a couple of minutes, then we can go for the other presentation if he didn't come.
Okay.
So he had a technical problem and he's going to join us now in a couple of minutes. Well, I believe that he might take some time to join us, maybe. So I think we can start with a second presentation till Engineer Haitham can join us. The second presentation with Engineer Ahmed Abdelghani from Allied Consultant. So Engineer Ahmed, please proceed, and you can, of course, share your presentation.
Engineer Haitham will be joining us in a few seconds. Thank you.
Okay, here he is. This. Thank you, Asma. I always solve it out. Haitham, we didn't hear you.
Good afternoon, everybody. I'm Haitham from ACUD. Sorry for being delayed. Do you hear me now?
Thank you for joining us.
You're welcome. You're welcome. Happy Ramadan for all of you.
So we can proceed with your presentation now. Please just go ahead.
Okay. Now I will share my screen. Just to check, share. Do you see the screen now?
Yes, yes.
Okay.
Please proceed. Yeah.
Okay. Here, just to, yes. Welcoming everybody. It's nice for us to continue in our fruitful cooperation with RICRI over the years now. I think this is the third or fourth year. We started in 2021. And it's our pleasure all the time to share the experiences and networking with all interested stakeholders in the industry and the region. Just a quick feedback or glimpse about the city for our new administrative capital. We started in our project in the new administrative capital since 2017, and as you see in the master plan, that our city or our new capital, it's the extension of the old new Cairo of the old capital of Cairo, the heritage Cairo, of course, everybody know about it. And we extended to the eastern side towards the Suez Canal and the Eastern Corridor. These are the 4 phases of the city. Our city total area, it's around 230,000 acres or fadans. We started development in phase 1, which is equal to around 40,000 fadan, and we finished around 70% of development of phase 1, and this is considered and a great achievement, of course, in the development and real estate industry. As you see here, the city is connected to Cairo from western side through the monorail, and this monorail will be launched by third quarter of 2025. It will link the western side to the eastern side of the city, and now, as of we are speaking now, city is connected from the north to the south side through the light rail train, which is already into service since 2 years before, and it contributes in transferring the employees who already moved to the government on daily basis. This is the proximity of the city and the location and the accessibility, of course. This is the distance toward the Suez port and to Sokhna port and to Port Said. Here we speak about phase 1. Phase 1, as you see here, this is the distribution of phase 1 that we have around 8 residential districts, in addition to mixed use areas, and of course the governmental district, the presidential area or presidential location, and we have also the diplomatic district. We think about the energy plan for our city in order to be sustainable and smart. This is our main pillars for the development, that we have to be sustainable, smart, and green. And we think, of course, for the energy aspect, we go for the technology of the district cooling. This is the topic that, of course, we shared with you, that we constructed already the district cooling plant, which is serving the cooling service for the governmental district with capacity 64,000, and the details will come later. This is some of the cooperation missions that we did with RICRI, with meetMED, starting from 2021. You remember the Corona days. Thanks God that now we become better than before. Starting from 2021, 2022, the workshop in Cairo, the visit to the cooling plant with the Arabian delegates in 2022, and we have the round table in 2023. Then the cooperation mission in Tunisia, which is 1 year before, and now we have and also the latest visit, it was in 2024 by RICRI. And finally, we have a European expert with asthma who visited us at the end of the previous year. This is now for the district cooling, and why we think about the district cooling and the necessity due to, of course, the energy saving that we have due to the sustainability that we are working on it. Sorry, now continue the screen. Due to the sustainability aspects and the saving in electricity consumption and also the other utilities. This is our district cooling plant and the components, the main components of the plant. Of course, at that time, we constructed the plant and the chilled water network, which serving the whole governmental district area, in addition to the financial district. And we have also a lot of connections and extensions to the neighborhood districts, the downtown area and the central bus station and senates also. We make use of the constructed plant to serve the neighboring area. based on the development and the actual demand. Of course, the component of the plant, our colleagues from Allied Consultants, our expert, Dr. Ahmed Abdghani, and our main contractor, Gas School, will take you in detail through the components of the plant, the chillers, the thermal storage tanks, the pumps, and so they will take you through the detailed concept and the technology that we adopted in that plant. Our project, when we think about our project, we think that we have to construct this project in a very tight time, of course, to match the movement of the government to the governmental district in the new administrative capital. So we think at that time that we have to work on a cost plus contract with the contractor in order to catch the development pace and execute the project as much as fast as possible. So we started in cost plus contract with our contractor Gas Cool, and we work on tendering the long lead items of the equipment separately as ACUD. We manage this tender, of course, in support of Gas Cool, but we try to take it outside of the contractors in order to manage the duration time and the cost as well. And we succeeded at that time to secure all the deliverables for the long lead items, as you see here on the schedule, in less than 1 year. And this was I consider it as a miracle, as after we finish and after we get the final piece of the equipment, the pandemic COVID happened, and we at that time, due to that we have all our long lead items, we didn't have a huge impact for the timeline of the project. And of course, as we speak about the district cooling, we speak about the plant and the chilled water network, which around 55 kilometers, that was under construction also in the same time. Here, this is the district cooling chilled water network. Sorry, the chilled water network. As you see here, that this is covering the government and the financial district. The government is the right side. I just want to make sure that everybody is hearing me. Is it okay?
Yes, yes, Haitham, we can hear you.
Okay, fine. So this is, as you see here in the mouse, that this is the right side of the network. You will find that the constructed district cooling plant is DCP1, which is around with a capacity of 64,000 refrigerating ton, and the other one, this is under tendering now, and we hope that we can start construction at that one maybe by the third quarter of this year. These serving the governmental area, the cabinet, the parliament, and the senates, and also we have connections below from this side to the downtown, some mixed-use buildings, and we have a connection here from the top to the central bus station. The other part of the network, as you see, this is serving the financial district. And here also the connection to the parliament, the nation court, and the other, as we speak in the presentation. Fine. Now for our expansion plan that we think about it for the whole city, for the whole districts. As you see that the DCP1, it's already constructed with a capacity of 64,000 ton. And this is our expansion plan for the coming plants over phase 1. You will see here DCP2, it is in the same district, and it will be on the same network, the loop that we constructed. This will serve the other buildings in the financial district and the other buildings in the neighborhood areas. We have another one here in the diplomatic district. This will serve the embassies, the United Nations building, the Arab Summit, and so yes, which is the other building on our development plan. As you know that we plan to move also all the embassies from downtown, from Cairo downtown to the city, to be near to the Ministry of Foreign Affairs and the presidential area. And we have another another one, which is DCP4. This is in the towers area in the south of the town, and DCP5 nearing to the central business district. Also, this area, we have at this location one of the tallest towers in the region. We have here Amazon Tower, one twisted tower with 240-meter high, and we have Forbes Tower, which is a zero carbon tower. This will be designed by Adrian Smith, who is the designer of Burj Khalifa in Dubai. This is some photos about the district cooling plant, the constructed one. And before we say thank you and give the anchor to my colleagues, I will show you a small video about the district cooling plan. Then I leave the floor to our consultant. Thank you, everybody, for your listening, and I hope that you get benefit of this presentation. Thank you.
Thank you so much, Haitham, for this presentation. Actually, I have been there many times in the new administrative capital, and what have been done there is really impressive in all the terms, honestly, and considering also sustainability within creating a new strategic capital like the new administrative capital is something a pioneer, and we would love for sure to consider it in our plans for the new cities, whether in Egypt or in any other countries. I have to mention that one of the very impressive also information we have that we are now in the process of building 34 new city in Egypt, which is a huge number, and it will be reflecting on the consumptions in terms of energy and any other facilities. So considering the new technologies, adapting the innovation ideas, and having focus on sustainability and green technologies and so on, while creating such a huge amount of cities is something really important. So before going through our next presentation, I will give the floor to our attendees. If you have any question, to send it via chat, and we can ask Engineer Haitham for it. But I will start with the first question, Haitham, if you allow me from my side. I want to understand to what extent is the plant utilized nowadays, and what's your plan for that? Because as far as I know, it's the first phase is built for the commercial building. So if you could give us more information about the utilization of it, and how can you manage this within the huge consumption that's going to be happen within the new capital.
Okay. Also, we have on floor from gas school team, our experts in the operation. They will correct me also, and they will add further info. But the phase 1 is built for the governmental district. The commercial aspects or commercial buildings, the demand is not as high as planned, but the current plant, around 80% of the plant at the peak time, serving the governmental district. So this is most of the loads now utilized for the government, and the government also something to highlight, that the government pay the consumption for us. We keep billing them with the tariff of the chilled water network, and they schedule the payments of the consumption, not only for the chilled water as one of the utilities, but for electricity, for water, and for the other services. So this plant, as I told you, that it's utilized nowadays for the government, and we think about the coming one in the same area as shown in the presentation, to be ready for the commercial buildings. The commercial building asking for the services now, it's around 4 or 5 buildings out of I think we have more than 60 buildings in the area. So still we have time to construct the other one. And the good side that we already constructed the network, so it will not be a huge effort for us.
Thank you so much, Haitham. I think we don't have any other questions, but please keep posting your questions in the chat box or in the Q&A slot. Then we can consider it later on. Thank you so much for your presentation, and
You're
please
welcome.
keep with us till the end of the session. I
Thank
give the
you.
floor now to Engineer Ahmed Abdelghani from Allied Consultant. Engineer Ahmed, please go ahead, and you can, of course, share your presentation.
Good afternoon. Good afternoon.
Good
Can you hear me?
Good
afternoon.
afternoon,
We
Dr.
can hear
Ahmed.
you. صباح الخير.
Actually, I was not given sufficient time to prepare the presentation, but I will continue on what is the advanced technology that we have highlighted before in our 2002 and 22 presentation. We have conducted several technologies in the areas, and each project, in fact, is completely separate from the other. It depends on the availability of resources, the availability of power supply, whether it is electricity or it is gas. It depends on the availability of water. So each project, it has its own merits. In the majority of the building, we are utilizing thermal storage, whether chilled water or ice storage. Thermal storage, chilled storage, as we can see on the graph below, the storage is reducing the chiller capacity by almost 20%. So we can, instead of the demanding power supply from the power plant, we are reducing the power demand by 20%. Adding to this, the diversified load of the district cooling plant. If you are planning to have building by building, then you are having the entire power of the building as a chiller in each building. But with said district cooling plant, you can merge and diversify the load between the offices, between the malls, between the apartment. So you can diversify the load with sometimes reaching 60% of the peak load of each building. So in conclusion, you can reach less than 50% from the total power demand that you are asking for. So this is reducing the capital cost, and we can see this later on our presentation. You can reduce the capital cost of building power plants and supplying the district, the areas. In cooperation with local code writers here in Egypt for HVAC, we have a decree now that any development more than 5,000 tons has to be with district cooling. Also, I would like to mention that district cooling is important when you have a high density demand, like downtowns, like if you need to have high-rise building in area where the density of the load is high. This is where district cooling is very, very useful and important. When you have villas or things like that, district cooling, the cost of it, of the network and the plant itself, it is not justified to have district cooling for such a scattered load. So each one has to have to check about the density of the load first. So we are seeing the thermal energy storage. It is reducing the peak power demand, and also it allows us to operate the chillers at their peak. So when the chiller efficiency at 80%, so we are running the chillers at 80% of their load, and get the best efficiency of this and save whatever energy is in excess to the chillers, and avoid start-stop of the chillers continuously. So this is enhancing reliability. Cost and the reduction in cost. If you are taking the first plant that we built, the cost of a chiller plant, it was costing around 30,000 Egyptian pound per ton. But the same, if you are taking a thermal storage and we are taking the storage out of the chillers, then we are getting around 7,000 Egyptian pound per ton. So we have reduced the cost of the plant by having the thermal storage, because thermal storage is just a tank, and the cost of constructing the tank is much more less than having a plant with the same capacity that we are withdrawing from the thermal storage. And this is definitely, we can run the thermal storage in non-peak hours. We can run the thermal storage by days or by night, depends on the area served. Let us say we are having an apartment building, so we can run the chillers on day and store the energy, and then by night we can switch off all the cooling towers and avoid any noise by night. On the contrary, we can, if you have an office building, then we are storing the energy by night, and then we are consuming it by day. As I said, next page. As I said, also we are using the gas. If we are having gas, then we can utilize either an absorption chiller, or we can go for natural gas engine that we generate from it, and this is connected directly to the compressors, and we can use the gas to generate the power and then run the chillers. Also, we can utilize the recovered heat to run the absorption. If we are having a steam, then we can do this. In the plant that we built, we have a combination between gas and between electric-driven chillers. This combination, it reduces the cost and get us a very high COP of the entire plant, because absorption chiller are working upstream of the electric-driven chillers. And the absorption chiller are working perfect when you have a return, when they are having the supply temperature is more than 43 degrees Fahrenheit. So we have the absorption chiller to run and give us a supply temperature of 50% of the delta T that supplies the plant. And this is enhance also the COP of the electric-driven centrifugal chillers. For the condenser and the cooling tower, when you have a cooling tower, we start and we have scarcity of water, then we try to utilize the sewage treated sewage effluent, and then we polish this at our plant and feed the cooling tower with the treated sewage effluent. And we have done this in the area of Burj Khalifa, where we have a plant which is polish the treated sewage and the feed 4 plants in the area. So we saved a lot of water there, because water there is also very costly. Also, we have in next one is we have also in Bahrain, we have a plant that we are taking the water from the sea and then filter it and have it as a backup water for the cooling tower. This is definitely increase the size of the cooling tower, but the water is much more less. We are not taking any water from the municipality, and we saved a lot of water in there. And also in Dubai, we had another plant that is run through the chillers, which we are filtering the seawater and take it from the sea and pass it to the chiller directly. There is no cooling tower at all. And this was also another constraint, because the building around no space to have any cooling tower, and the plant has to be in a basement. And this was a 30,000 ton refrigeration plant, where we have the seawater directly to the chillers, and the chiller definitely The tubes are titanium to withstand the seawater. And also the screen, the suction from the sea, it is through a suction screen located inside the sea. And then we are having blowers and the chemicals that we are discharging from the plant towards the screens to clean it continuously. And also we have a tube cleaning system for the condenser of the chillers. And this plant is actually, it is a very high-tech plant that we established 4 years ago, and it's running perfectly now. And we are trying to adopt the same concept in several other areas in Saudi. And so when we have adjacent, also we have a plant which is because there is no water at all that we can have. So we have what is called the water-cooled radiator. And this water-cooled radiator is a circulation of water, but it goes through radiators. And these radiators definitely, they are consuming much more energy, but it is covering that we are not having cooling tower. And this we did it in a health city. And this health city, it was in the middle of Jeddah, I believe, or Riyadh. It was in Jeddah. And the project is under construction currently. So these are different technologies that we have adopted, and each case is a case by case that we take in our design. So the engineer, she should take at the tools in hand and the sources available, and then decide what type of plant he should build. He could run also financial study and compare between having high cost water or high power demand. And this is the advantage of district cooling rather than chillers over the building. When you have a chillers over the building, you are tied with just one solution maximum. But when you have a district, then you have to think about it because it is saving a lot for the city complete. And thank you.
Thank you so much, Engineer Ahmed. I'll leave the floor for our participant. Do we have any questions, or shall we go for the next presentation?
Thank you, Dr. Ahmed, of course, for your contribution and valuable insights that you give us all the time. Thanks a lot, Doctor.
Thank you.
I think we don't have any question till now. Thank you so much for your presentation. Actually, I have been with your God's help many times in different presentation concerning the district cooling, but actually every time you add lots of more information and more insights that usually enrich our knowledge about this technology. So thank you so much. And I'd love to go now for the next presentation with gas cool with Engineer Mohammed Darwish and Engineer Mohammed Wahdan to give us an overview on the project implementation and technical aspects. So gas cool team, please go ahead and share your presentation. Yes, cool team. Do you hear us? I think we have a problem maybe with the voice. I wish everyone could have the IT expert as Enrich. We have Ibrahim Zawaida, who usually support us with these communication problems. So Engineer Muhammad from Gas School, do you hear us? If you have a problem with the connection, maybe you can text on the chat box. We just can't hear you yet.
Iman,
أيوة.
the colleague from Allied should be unmute his mic. He's a presenter already, but I can't unmute him. He has the privilege to be speaker. So if you have his mobile number, to WhatsApp him, to text him. Okay. Thank you.
No worries, Gas School team. We are waiting for you. Take your time to solve this technical problem. We still have time.
Iman, I received feedback from them that maybe you are muting the mic for them.
No. They are in the presenter view, so we are not muting them. They have the full access to do.
Right. Okay, I'll check.
It's maybe they have a technical issue. It happens. It usually happens within the online sessions.
Iman, there is a question for Engineer Haitham, if he can answer meanwhile while we are waiting. The question is on the chat.
Yes, sure. Okay. So we'll take some of your time, Haitham, if you are still available with us. Okay, so we will keep the question for till the end of the presentation.
Dr. Muhammad Wahdain? Is Dr. Muhammad Wahdain is our speaker?
Yes, بس هو مش سمعنا.
He's marked as a present. You are marked as a presenter now?
The mic is working now. Thank you.
Okay, thank you so much, doctor. Please go ahead. Thank you.
Thank you once more, Asma.
Okay.
So I believe you just need to share your presentation.
Okay, can you see it now?
Yes, we can see.
Thank you.
Thank you so much. Just go ahead, and I would love also to ask you for just to present yourself to our participants.
Okay, Engineer Muhammad Wahdan, Planning and Cost Control for Gas School Company, the main contractor of the district cooling plant. And with me, Engineer Abbas Safwat, he will introduce you.
Yes, this is good evening for all of you. This is Abbas Safwat, engineering manager from Gaston.
We will start speaking first about the district cooling plant and about it. The district cooling system consists of two main components: the district cooling plant, which consists of the chiller and the pumping system and the cooling towers, and the network, which responsible for transfer the chilled water from the central plant to the individual building. And every building has its ETS, which responsible for the heat exchanging between the chilled water pumped from the cooling plant and the chilled water which circulate in the fan coiled and HU and air conditioning terminals in every office in every building. The district cooling plant has many benefits. First benefits of it, the improved energy efficiency, as it is better than to be one district cooling plant with its main equipment, chillers and cooling towers and pumps, better than if every individual building has its plant, as it the efficiency will be discussed after that about the consumption of energy may be reduced to the half. Also enhanced environmental protection as it reduces the CO2 emissions, CO2 emissions to the environment. Also, we can use it for fuel flexibility, we can use, as Dr. Ahmed Abdani discussed, that we can use natural gas and electricity, and we can store thermal storage tank. We can store the chilled water in it and use it when we can in sudden loads or in any event. We can use it as we serve now governmental district cooling district and the financial district. There are many diversity in it, as the commercial malls work at night and the commercial building work at all the day. So there is many diversity between them. We can use it to store chilled water in the morning on all the time, and we can use it at night or vice versa. Also, reliability as the operation and maintenance team can work on place of the district cooling plant and serve it with skilled laborers, which can make reliability and durability, and the age of the plant will be improved. Also, it can provide comfort and convenience for the customers and in the client. It decreased the life costs for him, and we can remove the headache of spare parts and equipment contracts for maintenance from it. He can work with one server of the chilled water. Also decrease the building area used for the equipment. He can use the roof for offices, and he can use the basement for parking instead of using it for installed equipment. Cooling capacity of the district cooling around 64 refrigerant tonnage and on building area 10 and 500 meter. Also, we have finished it in 12 months. It was fast track project with a huge subcontractors as we make the building with Redcon and the MEEB with Hassan Alam and thermal storage tank with Arisco. It is a pioneering district cooling in the Middle East and in Africa at this capacity. Not in Africa, it is the best and the biggest capacity in Africa. The district cooling plant consists of 11 centrifugal chillers of 3,300 refrigerant tonnage brand train, Also, absorption chillers with capacity of 1,250 refrigerant tonnage with absorption chiller brand LG, and 5,000 refrigerant tonnage by 3 thermal storage tank. It is the 64 refrigerant tonnage with supporting system like field electric cooling towers, S16 with capacity of 400 and 4,125 refrigerant tonnage, and generators of 3 of capacity 1,250 kilovolt ampere. And also there are many medium and low transformers and pumping system which is responsible to pump that chilled water to the governmental and commercial building. The pumping system consists of 3 types: condensing water pumps and primary pumps and secondary pumps. Also, field electric cooling towers is responsible for condensing and cooling the chillers. Energy saving. The district cooling, if we used the traditional central air conditioning for each building with the electrical chillers for every building, the energy consumption will be 79 megawatt to 100 megawatt according to the efficiency of each chiller of each plant, which use water cooled or air cooled condensing. In case of we use the electrical chillers only in the plant, the consumption will be 55 megawatt, and so we reduce the consumption from 79 to 55. If we use the combined system by using centrifugal chillers and the absorption chiller and thermal storage tank, the consumption will reduce to 37 megawatt. We started the project at March 2021 with total production till now 150 million refrigerant tonnage. And this is the total production over the years. The production increase every year because of many building will be served with the district cooling plant from the governmental and financial area. The governmental building till now, I think 46 buildings have been served with the district cooling plant, and the commercial building till now, I think 5 buildings till now have been served from the district cooling. We have many. We have the operation maintenance team for the staff development team and the
Engineer Muhammad, we can't hear you anymore.
كنتش عامل حساب اصلا ان اقول الحاجات اللي جايه دي.
انت قلت انت قريت البرزنتيشن جاتك
انا
Sorry,
ما كنتش عامل حساب اصلا.
المايك مفتوح، احنا سامعينكم. احنا سامعينكم دلوقتي، اتفضل. أنا أعتقد I believe there is a problem with them. He's coming again, yes. Engineer Muhammad, do you hear us?
So, yeah, sorry for interruptions. Sorry.
No worries. It happened. But I think you need to, yes, to reshare your presentation one more time.
Okay. The operation scenarios of DCB, we can use the centrifugal chillers only, or use the absorption chillers only, or use the thermal storage tank.
Can
Okay,
you can you make your presentation in presenter view?
You can see the presentation?
شايفينها بس لو ممكن تعملها في presenter view من تحت على اليمين
Okay.
جنب الماينس في presenter view.
Okay, sorry.
No,
Sorry for interruptions. Thank you.
This is great. Go ahead.
Operation scenarios for DCB, we can use centrifugal chillers only, or we can use absorption chillers only, or we can use thermal storage tank, or we can combination between the centrifugal chiller and absorption chiller, and we can make a combination from the absorption chiller and thermal storage tank, and we can make a combination of all of them. We can use the thermal storage tank at the night, as we can produce the chilled water from absorption chiller or centrifugal chillers according to the tariff of electricity, or according to what's provided or what existed at the time, and we can store the chilled water and use it in all the daytime. The building that have been provided by chilled water, 46 buildings from the governmental district, and in addition to 112 buildings from financial district. I think 5 of them are in service. Value of saving, if till now we produced 150 refrigerant tonnage. If we use the traditional system, we will consume around 180 megawatts, but we now use 111 megawatt hours. And if we use the traditional, we will emission around 95 ton of CO2, and we now emitting around 57 ton of carbon or CO2. So the saving of electricity, 68 megawatt hours, 68,000 megawatt hours, and we save 37,400 tons of CO2. So we can improve the environment by reducing the CO2 emissions to achieve the sustainability and achieve environment protection. Thank you. And sorry for any interruption. Thank you.
Thank you so much, Engineer Hamad Wahdan. Do you have another presentation from Gas School team, or you covered the two presentations?
No, I covered it.
Okay, perfect. So we still have some times for question if you have any. And for Mr. Kamel from APU question. Hi, Kamel. It's very nice to see you once more. APU, by the way, is one of our main partners in meetMED project, and we had lots of closely work together. I just want to highlight that Engineer Haitham had a technical problem with his mic, so we want to be able to answer your question within the session, but we will make sure to have the answer in an email and circulate it among all of our participants. I would love also to mention that we are going to have to send you all the presentations with the photos by the end of today, maybe, or tomorrow, thanks to our colleague Asma. So if we have any question, we can take it now to Engineer Ahmed Abdelghani or Engineer Muhammad Wahdan. Otherwise, we're gonna end the session today. and we will consider having another webinars to cover the main experience within the rest of our 8 MENA links countries, meetMED countries, sorry. So I believe that we don't have any other questions. So thank you so much for all our participants to be with us today. I would love to extend our gratitude to ACUD with all their teams, to Gas School team, to Allied Consultant team. Special thanks to Engineer Ahmed Abdelghani, of course, for being with us so many times, and for Engineer Mohammed Wahdan and his team. My gratitude to all our partners at RICRI, Engineer Mustafa Hassanin, the head of this activity, Asma, our communication manager, Ibrahim Zuaida, our IT expert, and above all, our technical director, who was standing for all of that, Dr. Megid Mahmoud. Thank you so much all, and see you in the next webinar, and happy Eid ahead. Thank you.
Thank you. Thank you, and happy. Thank you.
Hello, Iman? Iman? email. So, could you hear me? Hi, Sam.